welcome, guys. Thank you all for joining us. My name is Hussein Alkhalaf. I'm joined here by Albert Diaz, our CEO and founder, and Wayne Land, who's our VP of Operation. In today's webinar, we're going to share with you our journey into the voice AI space. You'll see what we've discovered during our research and development, and then we'll run through a quick demo for you. Then after that, we'll talk about some common use cases in different verticals and what some of the competitions are offering. And then hopefully by the end of this call, you'll have a good idea of what to look for when you're choosing your own solution. Now, as Wayne mentioned, we're going to have a Q&A session at the end. So if you have any questions, please drop them in the chat. And then at the end, we'll answer all the questions you might have. And with that, I'll turn it over to Mr. Albert.
Cool. Thank you, Hussein. What's up, guys? Thank you for joining this conversation today on voice plus AI and really the hype and going from hype to production reality. Now, as voice providers, we understand that voice is real time from just about every perspective. Okay. And what I mean by that is you look at the tech, right? And it uses one-way UDP packets, which is designed for real-time applications. It's sensitive to jitter, latency, packet loss, etc. Real-time, right? We look at voice services and customer expectations around voice services, right? When a customer receives a call or makes a call, they expect that phone to ring instantly in real time. And if it doesn't, okay, let's say maybe it takes 5, 10, 15 plus seconds to ring, that's what we call pulse style delay or PDD. And customers really hate that, right? And the last example I'll give you is conversations. If you look at voice conversations, there's a certain fast dialogue that you expect back and forth. And if someone in a conversation goes quiet on you, you perceive that socially as awkward silence. So, to me, that's kind of peculiar. I really don't know a lot of other services where real time is so embedded into that concept, or where everything it touches, it just makes it real time. For example, we're talking about AI today, right? And I'm going to use ChatGPT in my examples today because they're the billion-dollar behemoth, right? Can't say anything bad about those guys. So I go to ChatGPT, I ask a question, and the reality is when I get that answer, I don't care if it took 1 second or 10 seconds. It's pretty much the same to me. So that becomes the foundation of our curiosity. What happens when you take something as real time as voice and you pair it up with another service like AI? So from there, we get ready to start the R&D. And when we start the R&D, we need to make sure that we're focusing on what matters, okay? We didn't start off with a checklist of features. That's not what was important. What we started with was core expectations, right? So if you see the theme, it's fast, right? So first and foremost, what we talked about, fast, natural experiences. I want to talk back and forth and feel like it's real. I need fast, scalable integrations. So no-code, low-code tools, they're cool, they're great. I love them, right? They're flexible. You can connect to anything. But the reality is they're not really scalable, okay? Let's say you're deploying 10, 100, 1,000, 10,000 agents, and each of those agents has 2, 3, 4 no-code, low-code integrations. Well, that becomes a problem. It's a nightmare because now you have all these individual manual integrations, APIs update, things change, and you got to manage it all. So that's just not scalable. Very cool, very powerful for ICV, but not scalable. So I need something that's going to be more maintainable as I grow the business. And then the last thing is fast, accurate answers. We all use ChatGPT. We know the deal. Sometimes it makes things up, right? And those overconfident false answers is what we refer to as hallucinations. Well, when I do that in chat, it's not a big deal, right? I'm working on an email, I'm working on a blog post. I can correct it and put it out. But when a customer is having a voice conversation with my entity and it asks a question, I need to make sure it's accurate because that's just a different circumstance. So this is what we say we're going to focus on when we actually go out to the market, start testing what's out there and understand it. So we begin the R&D and the promise is kind of obvious, right? Human-like voice experiences that resolve everything I need 24/7, open tickets, essentially creating real business actions, right? And we started demoing these things, and as demos, it's magical, right? It's just mind-blowing. But when you start pushing these products to their limits, when you start putting them in real world conditions, right? You introduce, for example, background noise, multiple people talking, tool execution, question asking, peak traffic time, the cracks started to show up in these services. Okay. So what were some of the things that we started seeing as we were testing? So first things first is execution speed and speech pacing was varying. It was weird. Okay, like I'd be in the middle of a call and sometimes things would be a little faster, sometimes it'd be a little slower. Throughout the day, I was having different experiences with the same vendor. I couldn't quite tell why it was varying. And by all means, I'm a telecom guy. Maybe I noticed a little bit more than the average person, but I could tell it was obvious. The next thing was agents often were speaking over me or they were waiting way too long, right? Anybody ever talk to a voice agent? You say something and it feels like it's like 5 seconds before it does something or it talks back. It felt awkward. Now, at the moment, agents were sounding robotic and we didn't know enough to know the difference, but we were thinking, man, we're using smart LLMs. Why does this thing sound robotic like this? Call routing and transfers were super clunky, right? The reality is these things, it didn't feel like they were made for VoIP to begin with or for integration with phone systems. And typically you were forwarding to the PSTN, forwarding back, maybe using Twilio numbers. It wasn't something that was native to your communication system. And then the last thing is we ran into it. There were too many confident answers that were incorrect or fabricated. And that's what we call hallucinations. The interesting thing was they weren't necessarily edge cases. We ran into some or all of these problems with pretty much everyone that we tested. So that's where the engineering team gets involved and says, okay, why? Why is this happening? What is it that's making this behave this way? It's good, it's just not great. So this is what we observed. This is what we learned, okay? The main problem was that all of these systems were built using the same underlying architecture. And that's that they were using what's called a pipeline architecture that uses text native components that were not built from day one. They weren't designed for real-time voice. And in addition to that, many times SIP was an afterthought, something that they tried to bolt on in a non-user friendly way. So we needed to understand, how do these systems work? What exactly is a pipeline system? How does it work? And how do we look at the different components so we can enhance those components to get to the level of experience that as providers we know we need to deliver? So the first thing is that we noticed that transcription first pipelines, right? And when I say pipeline system, I'm going to show you a diagram as to what it looks like, and I'm going to explain it real quick. Okay, so a pipeline system, what happens is the audio comes in and it gets transcribed. The transcription is sent over to the model. The model then interprets what's happening. The model gives you back text, and a text-to-speech vendor speaks it to you, like 11 Labs, right? And that process happens over and over and over. Well, starting with the transcription, at times the transcription can add lag. Okay, it can include errors, and it can lose what we call conversational signals. Okay, and on top of that, there's other little mechanical problems. Sometimes the transcription can buffer the audio to increase the accuracy, which can make it feel slower. On reducing conversational signal, you have what we call timing or prosody cues that get lost in conversation. We proceed from there, and we notice that turn taking was a little bit broken, right? So if your VAD system is not optimized, or if your VAD system, if your turn taking is heavily dependent on the transcription, we notice that that's not really optimal, right? Because the way the transcription works is that the transcription is grouped into chunks, okay? And those chunks might be a complete word, a complete, it may have punctuation in it, it may be a couple words. There's no specific pattern to the chunky. Different vendors are different. So when you're receiving conversation in chunks, you need to now measure if the person's done or not in chunks, right? So you need to wait a long time to see if you got to wait the next chunk to determine if that's ready, or you have to process the chunk, and that's where the problems start coming in. The next thing was that the systems where I could, for example, come in and pick models like ChatGPT or Claude or these things, the closed models that we know and we chat with, okay, those models run on what's called shared inference infrastructure. Okay, for the most part. And what happens is in a shared inference infrastructure, all of the inputs, all of the requests, they're batched. okay? And they're microprocessed for efficiency. Now, in the text world, that's okay, because in the text world, if my response took, like I said, a half a second or 1 second, it doesn't matter. But in the voice world, we know the deal. 500 milliseconds is a long delay for anything in voice related. So that is a bit of a problem there, the way that the models are run and the infrastructure that they're on. And then the last thing we noticed is that some people had good knowledge systems, and some people didn't. Some people had these systems where they would say things like, you put your website URL and we crawl it and we know things about you, or you can point us to here or there. But those systems, that architecture, that style, it's a little bit too Wild West. It's not designed for AI. It doesn't help AI focus on context that matters. So the question was, okay, why was it happening? We figured it out. We needed to understand, what are we going to do from here? So now that we know most systems are used building pipeline, this is some of the consequences of pipeline. We see vendors out there putting out solutions to try to improve pipeline. We got to get around that, right? So what are the conclusions that we reached? We had to build something a little bit better. We needed something that was speech native for real time, and it had to be practical, right? So I needed fast, natural conversation pacing, and I needed faster responses. I needed consistent performance. I couldn't risk having different experiences throughout the day or throughout different calls or in the middle of a call. I needed reliable turn taking. None of this awkward silence, none of this talking over each other, okay? I needed best-in-class knowledge with context that an agent could focus on so that it wouldn't grab unrelated information and perhaps have a hallucination. I needed flexible integrations, like I explained before. No code, low code, I love it. We have it, right? But the problem with no code, low code is not scalable, it's not maintainable. So I needed an easier way to be able to integrate faster so I can deploy faster and then maintain better as I got bigger. And then the last thing is it had to be UCaaS SIP native. I mean, just having to forward your calls to the PSTN, the voice providers on the phone, they know this deal, right? You forward to the PSTN, you forward back. That adds a lot of time and adds a lot of cost. The PSTN can break, it's extra legs, it's inefficient. Because at the end of the day, what we understand is that your customers don't want AI. They want outcomes. And this is the environment that you need to deliver outcomes for the customer. So what does designing for outcomes look like? Okay. So here, guys, shameless plug, we are going to explain how we built our solution, Flow.AI, okay, which is a service provider platform for delivering AI voice agents. And the first things first is we said we need to deliver conversations that feel natural, right? So how do we decide that we need to do that? Well, the first thing is we have to get away from the pipeline mentality, okay? And around the time that we started R&D, there was a technology that was getting a lot of attention, okay? It had already been around, but it was starting to really become relevant, and that was called a multimodal LLM. So most LLMs out there, the ChatGPTs and the Clouds of the world, right? They're text-based engines. They consume everything through text. And I know, let me take a step back. They are multimodal. You can't share images. You can't do things of that sort. Okay, so I didn't mean to misspeak that. But in the case of agent systems, they're all text-based. They're consuming the transcription from the transcription vendor before. So with a multimodal LLM, a multimodal can have more than one input. And in this case, direct audio. Right? So with a multimodal LLM, we're able to ingest audio directly into the model instead of through prior transcription. And then the model contains specialized training that helps it identify paralinguistic cues like tone, cadence, pitch, the kind of things that help you understand what's the emotion on the call. Was that a thoughtful pause? Did they finish talking? Is it my turn to talk yet? The next thing from there, and by the way, we reduce latency when you're doing that because you're taking the transcription out of the mix altogether, right? The next thing from there was the infrastructure that it's running on. So we said, okay, these models, these closed source models, the kind that you pay for and you get a token and you put in, these models, we know they're running on shared inference. It's just the way it is, okay? Instead, what we need to do is we need to run the models ourselves. And we need to run it on dedicated GPUs. And in fact, we're going to dedicate a call slot to the GPU for the entirety of the call. And that's going to ensure that you have a stable, consistent conversation the entire time. The last thing is you need a multi-layer VAD system. If you're basically just trying to do VAD with some of the voice equipment that's out there, you're not going to quite get it. So you need a traditional VAD, an extremely aggressive traditional VAD. Ours, for example, we sample 32 millisecond sample sizes, and we look at them for speechiness, right? So, and as you can tell, that's a very small sample size. versus when you're doing texting, chunking, you may be looking at several words or a combination of words or waiting for the next chunk. And then you need a neural vat, right? So a neural vat is essentially another model kind of running, helping on it that is designed to really understand voice and activity and things of that sort. And then you got to layer on the technologies that we know, right? Noise canceling, echo cancellation, to again, all for the purpose of really doing a good job of understanding. Is the person still speaking? Did they pause to think? Is it my turn to talk? From there, we say, okay, we need tools that are designed for, we need tools that are really easy to deploy, right? So yes, we talked about no code, low code. You got to have no code, low code in there. The reality is it doesn't matter what integrations you build or what your position is, there will always be some API that you didn't connect to or some obscure solution your customer wants to connect to, right? So you got to have the no code, low code stuff. But then to take it a step further, we need workflow integrations, right? I know there's a lot of hype around MCP right now. And I have my opinions on MCP. I think it's phenomenal for some things and not so great for the others. It's a little bit of a hype at the moment. Once the vendors improve their APIs, improve the documentation, then MCP is going to be golden. But with that said, today we need something a little bit better, a little bit more flexible. And not just that, it is known that the less the agent has to do, the better it will perform. And if you're using an agent with a lot of tools in it, for example, 3, 4, 5 tools, the more tools it has, the more likely that the model could possibly make a mistake. And it's every model, from the best of the best to the ones in the middle. Okay. So instead, what we need are workflow integrations. Integrations to the major platforms out there, Zapier, Make.com, N8N, where you can have deterministic, systematic workflows that are guaranteed to occur the way they are, and then you just integrate your agent to that one workflow. Right? So the idea with using workflow solutions, especially N8N, Zapier, Make, is you have 7, 8, 10, 12,000 integrations amongst them. They're constantly updating the APIs. They're simple to build out, right? And they're easy to maintain and scale. From there, we get into the knowledge. And guys, I don't know, maybe there's something else out there we haven't learned yet, but when it comes to AI and knowledge, I believe there's only one answer right now, and that is a RAG system. So if you've ever heard of RAG before, RAG stands for Retrieval Augmented Generation. And it's a mechanism, right, that allows AI to engage with specific knowledge. Now, why is this important? You know, I've watched a lot of demos, and there's one thing that I see in demos that irks me. When people say, you know, put your URL here, it'll learn about your company. Put your knowledge base articles here, it'll train to that. That is incorrect, right? The model does not train, the model does not learn. Once that model is released, everything that the model learned and trained stopped on the release date. That's it. What you can do for the model is supplement it with context, supplement it with specific information, and it needs specific information. Because you may hire, as an example, you may hire a new hire tomorrow, and sure, that new hire read your website, read your LinkedIn page, and they know something about you, but they don't know your policies. They don't know your product information. They don't know your internal SOPs. That's private information that wasn't available to it. Same thing is true about the models. Sure, the model might have some information about you, okay, but it doesn't know your details. But what a RAG system does is that a RAG system allows you to make knowledge, like URLs and documents, available to the model. However, it's not just file storage. The way RAG works is that you upload your documents along with descriptions, or you upload URLs like knowledge base URLs with descriptions. And then that content and that description is tokenized through a model. That tokenized information is then stored in a vector database with an interface that allows the agent to communicate to it. So now the agent, as it's operating, it's able to use its reasoning to put together what it's looking for, submit that request to the RAG system, and get back relevant information, sometimes more than one thing, and use its reasoning, the context, what's happening in the conversation to determine of that information, what should I be sharing right now? And then the last thing, guys, is a native PBX experience, right? For us, we did embed this directly into our voice solutions, and we do have modules that we're releasing for several solutions, but it's important that you have some level of native experience, right? The idea that you have to forward your calls through the PSTN, or you have to use a Twilio DID, or you have to use the most sophisticated CLI crazy thing to set up your trunk. I'm talking about one vendor in particular I tested, right? Popular internet vendor. it's not scalable, right? So you need something that feels more native. You want to be able to route the IDs directly to the agent. You want to be able to dial the agent by an extension, transfer to the agent, add it to a queue, an auto attendant, use your standard routing, and then you want to have out of the box support for typical communications components, right? Cold transfer, warm transfer summary, DTMF for outbound calls. These things should be native. They shouldn't be complicated to do. So what does this look like, right? I was talking about pipeline versus multimodal. So I know I have some technical people on the call. They probably want to see a little bit of detail. So I just got one side-by-side comparison here. So when we look at the pipeline architecture on the left, we can see that we receive the audio, right? The audio is then sent to the transcription vendor, and it's got to be transcribed. That's where you have the ASR or the STT, right? That transcription is then streamed in chunks over to the upstream LLM vendor. The upstream LLM vendor is doing the reasoning, the tool execution, the replying. It's replying and providing that text to the text-to-speech vendor like 11 Labs, right? And then from there, you have the audio out. That process happens in a loop. So in that process, your latency starts to stack up in between each step. Your conversational signals are lost. Rhythm, timing, intonation, right? You're losing these things. Your turn taking is not ideal. And your pacing is unpredictable, right? Because like I said before, some of these models are running on shared inference. They're micro batching the request. So instead, in a multimodal architecture, particularly one where you are hosting the model yourself and you can control the architecture, audio comes in directly to the LLM. Okay? No transcription, no streaming, no chunking. The LLM is able to ingest the audio directly. In doing so, we're reducing latency. We have less back and forth, faster handoffs. We're maintaining the conversational signals, okay? Because you're able to catch tone shifts in speech. You're able to determine things like frustration or urgency, okay? We then, from the model, we go straight to text-to-speech. We end up with cleaner turn taking, right? We end up with more consistent pacing because, again, we're running the model on a dedicated call slot inside the GPU, and we're not sharing that across the board. And again, to me, this is very important because, as an example, there is one particular vendor that has a horrible reputation and not providing their calls, right? There's one particular vendor out there that you buy their solution, it includes 10 channels. But then I hear all the time from both our partners, and you can see it all over Reddit, sometimes 2, 3 channels, they're getting errors. Sometimes 7, 8, 9 channels, they're getting errors, right? They tell you buy extra channels. You buy 10 more channels, you got 20 total, 12, 15 channels, you're getting errors. You're not actually getting what you need. Why? Because they're playing the oversubscription game. They're trying to have a really big architecture and they're just trying to balance the calls instead of really dedicating the resources to that call to deliver the experience that your customers are expecting. So with that, guys, I'm going to show you real quick what this looks like into production, right? We design our own solution. We do have a solution called FlowbotAI. It is a voice AI agent platform designed for service providers. It is multi-tenant and multi-system compatible. So everything we discussed right now was our journey into this process. What was important to us as providers using our experience? What did we learn when we tested? What did the engineering team figure out as to why it's happening? What did we decide is the solution? And now we're going to see how we bring that to real life. So if you give me 1 second, I'm going to change screens. So guys, in here, this is a NetSapiens multi-tenant PBX platform. It is the solution that we use internally. We partner with NetSapiens. We do offer this to our partners and to other service providers. So for this particular module, what we did is we created the embed module, which essentially embed the native users inside the system, right? So historically, you would have your users here. And what we've done is that we've added a new option called AI voice agents, right? Adding an agent is going to be like adding a user in the system, okay? You're going to give it an extension number right off the get-go. You give it a name. You pick your model. Now, these are not models like ChatGPT and Claude of that sort. These are the actual models that we're running on our dedicated infrastructure that have the adaptation necessary to make them multimodal, okay? You pick your voice, you drop your prompt. And then, of course, you pepper it with some cool tools and things to help people out, like an inline option to, as you're writing out your prompt or designing it, instead of having to find your tools, find your tool name, find your RAG information, you could actually just go ahead and reference it like any other software editor and actually go ahead and add them in there, right? Now, once you add an agent in the system, it's important that agent be a user in that system like anything else. So these agents are native users inside the phone system, whether it's NetSapiens or 3CX or Portal One or any system that you're using, it's compatible to be a user inside the system. Now, once you have a user, right, you need to have access to everything in one place in a simple way to consume, right? We don't need 1,000 features. We need the important features. So on the profile side, voice activity detection is tuned from factory, but if you find yourself wanting to really, really tune it, you do have the ability to tune. Now, this is one of the things you'll notice is different. When you look at some of the pipeline vendors and you look at their VAD settings, you'll notice that their VAD settings are in seconds, or they're in words, or they're in characters. Our VAD settings are in milliseconds. Okay, and every 32 milliseconds is a different sampling size. You can go ahead and bring it down. Okay, we start at 384 milliseconds. You can bring it down to 250, 200, no problem. Okay, we proceed from there. We talked about tools earlier, and we said, yeah, tools, no code, low code, super cool. I like it, flexible, just not scalable. You have your no code, low code experience, right? Add your parameters, put your stuff in there. But a little bit more important than that, what you have is native integrations to the big workflow platforms, right? So as an example, we're looking at Zapier. We actually have a FlowbotAI app inside Zapier, Make, and N8N stores, marketplaces, repositories, respectively. So you're able to go in there, activate it, and here we can see, I'm showing you right now a small workflow that I have connected to this agent. You can see that it's using the Flowbot agent connector that we installed from the Zapier marketplace. And this is just a real basic example I did. The agent actually triggers the workflow. It looks up a contact. It creates a ticket for that contact. It sends a notification on Teams. It sends an email through Outlook. Okay. And then once you build your workflow, all you need to do is hit the publish button. And when you hit the publish button, it automatically creates the tool for you. You don't have to do anything. So what happens is you create the tool, you add your API key, the Zapier, Make, or N8N systems are able to connect to our system. It's able to subscribe to each other and communicate. And then once you've built out your workflow, because the app knows what your workflow is doing, the parameters it's going to need for the action or the trigger, it's able to automatically create the tool for you. So here we can see that it put in the custom endpoint URL. And in my particular case, I was opening a ticket. So I went ahead and put the fields that I knew I was going to need for that workflow. Contact, email, subject, description. Okay, and a couple other things in there that we could explain afterwards. We add the call ID in case you want to update the call after the fact. And then the last piece here, let's go back over to our agent, would be knowledge, right? So again, knowledge is very important. You can't just have file storage. You can't just be scraping websites. Your agent is not going to learn or train. That is not true. What you do is you inform it with the information that it needs when it needs it. So the way you manage knowledge in a RAG is you first create a collection with a description. Collection might be knowledge-based articles, troubleshooting guides, SOPs, policy information, right? A particular subject of documents for you. And then once you do that, you start adding sources to it, right? So you pick the collection for example, FAQs, you give it a name, you describe what's inside of it so that it understands it, okay? You add your URLs, you add your documents, you hit save, we tokenize it, we store it in a vector database, and then your agent is able to engage with it. Now, going from there, you got simple call control, right, that you're going to need to have in case you want to tune the way your agent behaves throughout the call. And then the last thing is the ability to test your agent directly in the portal. So a lot of these solutions, you have to call the number to be talking to your agent. It should be easier than that. So in this case, you can make adjustments to your agents. You can tune your prompt. You can tune a tool. You can tune your knowledge. And then once you're done, come in here, click the button, and go ahead and talk to your agent. Now from there, I'll show you a couple more things. I believe I have some samples here. I can bring it up. So here we have a sample call I did the other day. I believe this is a couple days ago. So I'm talking to the agent. This was a stress test. Talking to the agent, I got people screaming in the background. It picks up one voice. It realizes it's not me talking. It continues to talk, right? But it didn't stay talking. It didn't talk over me. It realized it. Then it asked me for my name. I gave it my name, guys. My name is Albert Diaz. Not uncommon, but Diaz is unique, right? And it got the spelling right. It asked me for my email. okay, and I try to trip up the system. I give it 83labs@gmail.com. And it is actually like this. It got the context right. Okay. Now from there, I'm opening up a ticket. It's asking me, what are your problem? What's happening? I give it a real ridiculous answer. My printer doesn't work. What is it? I click print. It doesn't happen. So it decides it's going to open the ticket. You can see that it executes the tool call and it shows me the results of the tool call directly inside of here. And I don't have it in this demo, but it's in our next release. We actually have toggles for all of these settings. So you're able to see tool calls inside of it, diagnostic information and reasoning information, because this is the kind of stuff you need access to, right? At the end of the day, agents are a blend of art and science, right? Predominantly art on the prompt and science on the tooling, but there isn't definitive rules. There's only suggestions to how it works. So when something breaks, it's not like VoIP. You look at a SIP log, you say, okay, this is what it is. You got an add issue. This is what it is. You didn't negotiate the codec. Sometimes you got to do a little bit of exploration. So having all of that diagnostic data to you, it's really important so you can isolate things quickly. And then here I have another example, if I'm not mistaken, when I was engaging with the RAG system, right? So I call in and I go, what are your business hours? And it absolutely grabs the business hours and it answers me, right? Our business hours are Monday through Friday, 9 to 5. Then I trip it up and I ask it 2 questions to see if it can mix things. What's your location and services offered? Okay. And if we have any old school Jerky Boy guys on here, maybe you'll remember this. Location is 123 Big Walkway next to Small Walkway in Central Florida by the Gator statue. Yes, I put that ridiculous thing in there, and it was exactly like that because I wanted to see if it was going to maintain it or adjust it or influence it in any way. And then it also answered my second question altogether. Okay. I keep asking it questions. Everything's good. At the end, I say hang up deterministically, and it drops the call. So guys, this is what's necessary to be able to scale and grow, right? You need a good infrastructure that's going to give your customers the kind of fast experience that they're expecting from voice. Because like I said before, as soon as you add voice to something, it's real time, right? So you want to make sure you deliver that fast real time experience. You want to make sure you have good integrations to be able to deploy quickly and to be able to maintain your customers. And then you want to make sure you have grounded knowledge sources to mitigate, because you can't mitigate the amount of hallucinations an agent has, so you can continue to keep your customers' trust and they can keep their customers' trust. So let me go back over here. Guys, that was it there. That's the end of my part for today. So we discussed, what did we find during our R&D? Why was it happening? How do we have to design it? And I just showed you what that looks like in production. When you follow that model and you build that way, this is what you can end up with. So with that, guys, I will go ahead and hand it back over to my colleague Hussein, who is going to ask you guys a couple questions if you don't mind. Hussein, you're muted, buddy.
Sorry about that. Yeah, so thank you, Albert. So I just launched a poll real quick. It kind of helps us guide us into the future. It's just a simple 3 questions, if you don't mind, if you guys don't mind answering here real quick. So again, if you just click on the polls, 3 quick questions. The first question is, are your customer asking for an AI agent solution? If you guys don't mind answering that real quick for me. And no. Okay. Second question, do you sell or manage any AI agents currently today? All right. So again, I figured the most popular answer, yes, everybody's asking about it, and some people are offering, some people are not. And then the last question is what is a vertical you believe that could benefit from AI agent solution, and how? Just a quick 1 sentence answer, if you guys don't mind, that would be very helpful to us.
Cool.
All right, guys, I appreciate your time.
Thank you, guys. That kind of feedback does help guide us in what we're doing for the future.
Yeah. And with that, I will turn it over to Mr. Wayne.
And just to remind everybody, we do see some questions coming in. Right after Wayne shows a piece that he's going to show right now, we're going to get to Q&A. We're going to address all of them for you.
And if you have any additional questions, please drop them in the chat also.
Excellent. I appreciate all the answers we got for the polling questions. I think it's interesting when we talk to people, a lot of people in different places in terms of how they perceive the market and where their business currently resides. So real helpful. Albert gave you a really good picture on what we call our 18-month journey of how do we make this work for our partners? And it was a very technical discussion, but we also had some business discussions around what voice AI agents mean to us and to the market more holistically. And fundamentally, the answer we came up with is going to change everything. It's going to change a lot of things for us and for our partners and for our partners' customers. So primarily what, if I have to sum this up in a kind of single description, is the value that voice AI agents bring to the customer far exceeds what a traditional voice solution, and that includes, some of the most sophisticated UCaaS solutions. Voice AI agents will eclipse the value, and that's important because customers buy on value. So when we start to look at what this means for us, we start to look at the common use cases, right? Because when you see what is accomplished through a common use case, and this is what a voice AI agent can do in a very simple form, and this is what we can deliver right now today. We have things like a receptionist agent that can greet a caller, answer questions, route calls, book appointments. A sales agent, which, if you think about it, normally if I had a sales inquiry, I got to wait for a salesperson to respond, but an agent can do that virtually instantly. They could also qualify that lead, capture any kind of requirements or details that particular customer is asking about, and then trigger a next step workflow into something like a CRM so that a human can follow up. Support agent, kind of in the same sort of vein here, is that there's a lot of perceived value around being able to just offload some calls that are very, very common requests that are easy for a voice AI agent to answer. And then you have the ability to do triage. So capturing details around the actual issue that customer is reporting, creating a ticket or updating a ticket, and then if it's needed, escalating that to a human to then take over. On the scheduling agent side of things, booking and confirming appointments, real simple things that people get a lot of calls around that are able to be automated. And so things like reservations, reschedules, and triggers for reminders or updates to your appointment are also things that we see a lot of customers who are expressing interest around because they see the value here. So if we start to look at this through the lens of a vertical situation, for example, and Albert, if you don't mind going to the next slide, if in verticals, you can get even a better picture of where they start to see the value of employing voice AI agents. I'm going to use healthcare because that's one I probably have had the most discussions around. And if you think about this, a lot of the day-to-day that teams at healthcare clinics or healthcare organizations are dealing with, it's about calls that are for scheduling, reminders for appointments, rescheduling, potentially even billing. But they get a high volume of calls, so it's easy for them to see the ROI in automating these things. And their approach to automating these things is to workflow into applications like EMR or EHR systems that they currently own today. And the other benefit is because the agent can be equipped with knowledge, they can feed their policies into RAG, as you saw, and that agent has access to those policies and can answer simple questions and handle things in a call it SOP manner, similar to what they would expect a person to do. Now, we have a lot of partners here who are MSPs. And so, naturally speaking, we've had a lot of discussions with our partners as they're looking to implement this here internally. And there's a twofold benefit, actually. One of which is these are customer facing tools. So, customer calls and logs a ticket. That customer hears the voice AI agent. The presumption here is this is a good experience, and that their customer taps them on the shoulder and says, "Hey, I love this. I want one for me." Right. So now they've got a sales opportunity. But there's also the ability to just automate some of those more routine tasks or phone calls, or phone calls and tasks related to those phone calls, because they can workflow into their PSA or their CRM. And again, they're going to leverage the RAG here to take their support processes and any potentially unique support requirements that they may have, and embed those as knowledge for the agent to then access. This is one of those leave behind slides. I'm not going to go through every one of them, but I think it's helpful if you're thinking about, like, do I have customers that may value this? This is a good starting point to kind of think about how somebody in various verticals may utilize this. So, Albert, if we can go to the next one. So I've hammered this value thing here a little bit, but I think it's important because it ties to this next slide. People pay a lot more for things that they value. And this is a premium product for the most part. So if you look at some of the leaders in this space, you get RingCentral, one of the first entries into this market with a AI receptionist. They sell at $59 a month. That includes 100 minutes. If you go over that, there's additional usage charges on top of that. If you look at Nextiva, if they use a term here that I'm going to not necessarily be able to quantify exactly, because I don't know exactly how they characterize every interaction, but they have 100 interactions that cost you $99 a month, and then 99 cents for every interaction thereafter. But you can assume that the interaction meets some threshold of that agent being called to do something, right? So when we see this, we know that this is being sold as a premium. And I think that you take what I'm going to characterize as a limited use case of a AI receptionist. You can even get a lot of value out of something with a more limited scope of things that it's going to be able to do for the actual customer. So it's exciting to see that we've got this high value product that we can charge a higher dollar with higher margins. And in fact, when we start talking to my customers, they're getting in excess of 70-80% markup on their costs. So they see this as one of the prime drivers of their business, not only because there's a lot of interest, but because there's a lot of revenue and a lot of margin to be had in this particular market. So, Hussein, I'm going to turn this back to you.
Wait, before you do that, I got one comment here. I've been in the voice space my entire life. And one thing that I've noticed is that over the last 10 years, the voice industry has gotten somewhat cannibalized. All sorts of people have come in to take revenue from it. And all sorts of new forms of communication have come in to take conversations away from it. And if you've been in the space for a long time, you've noticed that the amount of minutes that customers are using has been going down, okay, depending on what kind of base you have. So what's exciting about this is not that just there's some other service that we can sell, but we're bringing voice back. What we're doing is we're bringing solutions that help create minutes versus the situation we were in, which is we're losing minutes. Why? Because people are using chat, people are using SMS, people are using ticketing systems, they're using portals. The new generation doesn't want to talk to people sometimes because they know it's a person on the other side. Now what we're doing is we're bringing in a solution, and we're not just bringing back regular wholesale telecom minutes at the kind of rates that the carriers pay and charge, but we're bringing back expensive minutes. And no, I don't think it's going to be $1 a minute forever, but it's exciting to see it there, right? Because it's so much higher than anything else that we're billing today. So this isn't a $4.99 add-on, a $10 add-on. This is an opportunity to have some substantial revenue from your customers, again, doing what you've already been doing for a long time.
All right, guys. So I have a question here, Albert, from Jake. Is it possible for the AI agent to get response back from Zapier, and then make a decision, example, transfer to a queue or call another tool API? Or, or is it once the data is collected, it's sent to Zapier and then ends the conversation with the caller?
I'm going to show you. So let's change the screen share. You should see my browser again. Okay. So the answer is you can update an agent mid-call. Okay. And through the API, you can start a call. Okay. If you want to do like outbound calling, for example, we do support outbound calling. I know some people are not, but we do support it. It is, it has the right policies in place. We have the right acceptable use around it in order to allow you to do it. So you can update the agent anytime mid-call. And in fact, that opens up all sorts of cool things. Like I have a demo where the agent is doing sentiment analysis. If the agent believes that the customer is upset, it triggers a workflow. The workflow sends me a message in Teams. And then I'm actually able to receive a summary of what's happening there. And then from there, if I want, I can kind of like listen, whisper, barge, if you want to think of it that way. So I can tell the agent, start streaming me the whole conversation. Or I can tell the agent, I can give it a soft command. Okay, this is the problem. Check if so and so is available. If they are, let the customer know you're going to escalate. I can do it as a soft thing. I can do it as a hard thing, right? So just stop talking right now and do it. So the same kind of concepts, you can do that there. Now, Zapier specifically, Zapier runs an asymmetric API, right? So what does that mean? When you send Zapier the initial webhook, they give you a 200 OK. That 200 OK does not contain information. It's only a 200 OK that the webhook was executed. So what that looks like with the example I had on the screen. I believe I was executing a Zapier workflow here. Yeah, okay, so perfect example. I executed the tool. That is the 200 OK from Zapier. So all they do is let you know that it's happening. Now, if you want to get information back from Zapier, we took care of that for you. So let me go ahead and edit this one. We can add a step right here. So you see create ticket. So after I create the ticket, I want to add a step. And what I'm going to do is I'm going to send agent response. And then I can configure it. So this allows you, right? Because again, it's a limitation on the Zapier side. This allows you to actually go ahead and send information back to your agent. And because you have the call ID from the initial execution, bam, your workflow knows and the system knows what call should be updated. Okay. Now, if you're running your own backend, you can provide the information in the 200 OK. If you're using make.com or N8N, there are ways to get the original 200 OK to maintain the original data. Okay. But if you're using something like Zapier, which doesn't allow it, then you have the ability to just go ahead and add an agent response as part of the workflow. Now, since we're here and we're talking about this already, guys, this is what enables things like outbound calling, right? So now you can build a workflow in Zapier as an example that is looking at your CRM, is looking at your inbound leads, it's looking at your website, it's looking at whatever. And if it feels it needs to make a call, it can trigger it, wake up your agent, make a call, and it can use this to send it information, right? Or the example I gave before, which we're working on, like for the call center world, a call comes in, the call gets escalated, you get involved, and you're able to essentially whisper, listen, barge to the agent through text. So this is what's going to let that happen. Well, that was a good question.
Excellent. Got a couple more questions here for you. Albert, this one looks like it's addressed to you. You mentioned a Twilio number for the handoff. What kind of problems does that cause?
So this one I can tell you. So this is the deal. When you're using a solution that gives you a Twilio number, right? Typically, you don't own the number. They're renting you that number. The number's theirs. So that's like the first problem. God forbid you publish that number anywhere, you can't port it out, you lost it. That's the way to piss off a customer, right? The second thing is the guys who are using the Twilio numbers, typically what happens is you got to transfer calls to that number. So now when you're transferring it, the call leaves your system and hits the PSTN. As far as your system is concerned, that call is over, right? As soon as it hits the PSTN, I have no insight on that call anymore. So now the call is being handled by that external agent system. That agent system determines it wants to send the call back to me, right? So I need to have backdoors for that agent. I probably have to have certain DIDs so that that agent can reach certain people by DID, perhaps add DIDs to queues. If it's going to transfer it to a queue, I got to set up a lot more routing. And at the end of the day, they're going to transfer it to the PSTN that's going to come back. And if you're a telecom guy, you realize every time you transfer it to the PSTN, you're adding 2 legs. That's 2 places where something can go wrong in a place where you're having real-time voice and everything has to be perfect. So typically, that's what you're looking at. You're looking at transfers over the PSTN, and you're looking at the lack of easy, simple routing between the agent and the main phone system.
We tried an agent in our office, and we kept getting complaints that it was not responsive, almost like it wasn't paying attention. Are you saying that the multimodal approach helps that situation?
Specifically, yes. All right. So the idea behind responsiveness comes down to 2 things, and they both impact it different ways at different times. So the first piece is the transcription part. Because the audio has to be transcribed, and transcribing adds a little bit of delay, because that transcription has to be turned into chunks and sent in chunks, because the model needs to receive the chunks and determine, do I need to wait for the next chunk or am I done here? All of those things add delay. They add latency. Then you top it off with that once it finally gets to the model, if you're using a model like a ChatGPT, and again, I'm not knocking them, guys, it's probably one of the best products out there for text. But when you're using a model like that for voice, and I'm not talking about OpenAI Whisper, I'm talking about just regular ChatGPT, right? Then you're sending it to a system that's running on shared inference. And they're going to microbatch the processing of those requests. So you're always running the risk that if that system is overloaded at that moment, remember, if you're doing something in chat, like I said earlier, if the response is 1 second, 5 seconds, 10 seconds, I don't feel any kind of way, I don't notice. But when you're in the voice world, every 500 milliseconds is dramatic. And that 500 millisecond or 1 second difference, that's where you get the speech pacing, that's where you get the awkward pauses, that's where you get all sorts of anomalies.
One more question here for you. Let me just try and summarize this. So I have a customer who's got a bunch of different documents that we would like the agent to be able to access. Can one agent access more than one document?
Yes. But I'm going to add a little something here. In this conversation, a lot of answers are yes, kind of, and no, maybe so, both. It's very seldomly black and white. Okay, so I'm going to put it with this. A single parent can raise 5 kids by themselves. They can do it, of course they can, right? Doesn't make it a good idea. So an agent can have access to as many tools and as many documents as you want. But the more you do that, the more you're opening up the possibility of a mistake. So typically speaking, I think I said this the other day. One of the fastest way to fail with agents is to try to deliver an agent that does everything overnight. Right? When you come into a customer and say, I'm going to do everything. I'm going to do your tech support. I'm going to route your calls. I'm going to answer your questions. I'm going to do this. I'm going to do that. I'm going to do this big agent. Probably not. Right? Your prompt is going to start getting really big. There's going to be a lot of conditions. The lower in the prompt you get, the less context you have, the less prioritized it is. The more tools you're running, the worse. The more knowledge you have access to, the more knowledge you're looking at, the more likely you could have a hallucination. So typically what you want to do is you want to have a couple collections. You might have a couple things inside those collections. And by the way, I just said couple twice. That's already 4 documents. That's perfectly fine, right? If you have an agent that's just answering questions, perhaps it answers policy questions and support questions. Sure, 2 collections, 10 documents inside of them, fine. You just want to be careful to not give it too much context, right? As an example, I showed you guys there, you can upload URLs, right? And you can control the crawl depth. Well, if you put 2, 3 URLs, 4, 5 URLs, and you put a crawl depth of 2, you're fine. If you put 50 URLs with a crawl depth of 5, you just read way too much information. So you want, give it as much as you need to give it. but don't give it extra just because. I know that was a long explanation. I tend to do that.
Well, it was on point. It's a multi-factor answer because it's a little bit of a complicated question, but frankly, it's doable. That is it for our questions, guys. Unless anybody else pops anything here in the chat, I'm going to turn it back to Hussein.
Yeah, Albert, can you pull up the screen again?
Yeah.
So I know, guys, we just have a couple of minutes in here.
That's
Yeah, as you're
interesting.
pulling that up, I'm curious how many of you have been in this space for a period of time, in the MSP space, I should say, not the voice AI space. So, because I think we're going to talk a little bit about maybe some things that may interest you here.
So as most of you know, guys, a little bit more about us, about RingLogix. Sorry, my video keeps turning off. So we're bringing a carrier-grade UCaaS and AI voice automation and automated billing together in one powerful white label platform that's built for partners who want to launch, scale, and fully own modern communication business. Albert, if you could go to the next slide. Now, if you guys like this webinar, we have a few items that we're going through, some webinars going over some of these topics in here. Obviously, get a recorded video of this webinar. It will also be on YouTube page, and then you'll also get invites for these different webinars in here that we'll be holding here shortly.
I'm just going to add to what Hussein is saying here. So hoping maybe you guys saw some value out of our presentation here today. And if you're really in this business, we do have a partner program. If you're looking to add voice AI agents to your business, that's actually a great way to start. If you're thinking more holistically about a full voice stack, we've got everything to cover you there. So if you're interested, Hussein's email is right here at the bottom. Or if it's just an interesting topic to you, these would be some of the things we plan to do over the next couple of months. So stay in touch or get signed up with Hussein, and we'll make sure you're notified about any of these.
Cool, guys. Well, listen, thank you, guys. I appreciate you joining us today for this conversation. We will be having more conversations like this in the future. So if you found this helpful, or if you have ideas and things you would like to hear about, please reach out, let us know, and we'll be having more like this. With that, thank you and have a great day.
Thank you, guys.
Thanks, everybody.
Bye.